Welcome to our deep dive into configuration management, best practices for system stability. In today's complex IT landscapes, ensuring that systems run predictably and reliably is paramount. But what exactly is configuration management? At its core, configuration management, or CM, is a process used to maintain consistency of a system's product performance, functional attributes, and physical attributes with its requirements, design, and operational information throughout its life. Think of it as defining and enforcing the desired state of your infrastructure, from servers and networks to applications and services. Without CM, managing systems often devolves into manual, ad hoc changes, leading to inconsistencies, errors, and significant downtime. CM introduces a disciplined approach, moving us away from reactive troubleshooting towards proactive system health and stability. The absence of robust configuration management can lead to what we call configuration drift, where systems deviate from their intended baseline, often due to manual interventions or unmanaged changes. This drift is a primary cause of instability, security vulnerabilities, and operational inefficiencies. Imagine spending countless hours debugging issues only to discover a slight configuration mismatch across servers. This chaos translates directly into significant costs, increased downtime, security breaches, compliance failures, and wasted engineering effort. Conversely, effective CM offers immense benefits. It enhances system reliability by ensuring every component is configured correctly and consistently. It drastically reduces deployment times, potentially by 90%, and can cut downtime by up to 50%, improving security posture by enforcing known secure configurations. It's not just about efficiency, it's about business continuity. Effective configuration management is built upon several foundational principles. First, there's desired state configuration. This principle dictates that you define precisely how a system should look and behave, its ideal state. Instead of telling a system how to achieve that state step by step, you declare what the final state should be. The CM tool then intelligently works to bring the system to that specified state. This leads us to the second principle. Impotence. An impotent operation is one that, when applied multiple times, produces the same result as if it were applied only once. In CM, this means you can run your configuration script repeatedly without causing unintended side effects or errors, ensuring consistency. Finally, version control is crucial. Just like source code, all configurations should be stored in a version control system like Git. This provides a complete history of changes, enables easy rollbacks, and facilitates collaboration among teams, providing an invaluable audit trail. To implement these principles effectively, you need powerful tools. The landscape of configuration management tools is rich and varied, offering solutions for virtually every need. Prominent examples include Ansible, Puppet, Chef, and SaltStack. Ansible, known for its simplicity and agentless architecture, uses YAML for playbooks and SSH for communication, making it easy to get started. Puppet and Chef are agent-based systems, meaning a client runs on each managed node, communicating with a central master. They typically use a Ruby domain-specific language, DSL, for defining configurations and are very robust for large, complex infrastructures. SaltStack, also agent-based, uses a Python-based DSL and a high-speed messaging system for highly scalable and responsive management. Each tool has its strengths, whether it's ease of use, scalability, or flexibility, and choosing the right one depends on your specific environment and requirements. Exploring these tools is a critical step in building your CM strategy. Our first best practice hones in on the foundational concepts we discussed, defining the desired state and ensuring idempotency. It's not enough to simply react to problems. You must proactively define exactly what correct looks like for every system. For instance, you might define that server web 01 must have Nginx version 1.20 installed, port 80 open for HTTP traffic, and a specific SSL certificate configured. This comprehensive definition acts as your single source of truth. Then, you ensure your configuration scripts are idempotent. This means that if you run the configuration to install Nginx 1.20 on a server where it's already installed, the script should do nothing, or only make necessary adjustments without causing errors or reinstalling unnecessarily. This apply changes repeatedly without unintended side effects principle is crucial for predictable and safe operations, allowing for frequent and confident updates and audits without fear of breaking working systems. The second critical best practice is to version control every single piece of your configuration. This means treating your infrastructure as code, or infrastructure as code (IAC), and managing it with the same rigor you apply to application source code. Tools like Git are indispensable here. By storing all your configuration files, from server settings and application parameters to network device configurations, in a Git repository, you gain a powerful audit trail. Every change is logged, along with who made it and when, providing complete accountability. Need to roll back to a previous working state after an issue? Git makes it trivial. Furthermore, version control facilitates seamless collaboration among your team members, allowing multiple engineers to work on configurations concurrently, merge their changes, and review proposed modifications before they are applied to production. This approach significantly reduces human error and enhances traceability. The third best practice emphasizes automation as much as possible. Manual processes are inherently prone to human error, inconsistency, and delays. By automating configuration tasks, you not only eliminate these risks, but also dramatically increase the speed and reliability of your operations. This includes automated deployment of new servers and applications, automated patching and updates to ensure security and performance, and automated testing of configurations to validate their correctness before they impact production. Think of automation as building an assembly line for your infrastructure. Each step is consistent, repeatable, and fast. Tools like CI/CD pipelines integrate seamlessly with CM tools to create fully automated workflows from code commit to production deployment. This allows your engineering teams to focus on innovation rather than repetitive, manual configuration tasks, ultimately leading to greater efficiency and system stability. Our fourth best practice is to embrace the principles of immutable infrastructure. This paradigm shift means that once a server or container is deployed, it is never modified. Instead of patching an existing server or making changes in place, you replace it entirely with a new, updated version that incorporates the desired changes. Imagine building new cars on an assembly line rather than constantly repairing old ones. This approach has profound benefits for consistency and predictability. Every instance is identical, reducing snowflake servers, unique, manually configured machines that are difficult to manage and troubleshoot. When an update is needed, you build a new image or container with the updated configuration, deploy it, and then decommission the old instance. This significantly simplifies rollbacks. If a new deployment causes issues, you simply revert to deploying the previous known good image. Technologies like Docker and Kubernetes are natural fits for implementing immutable infrastructure, making it a cornerstone of modern, stable systems. The final best practice is the continuous process of regular audits and compliance checks. Even with robust configuration management in place, configuration drift can still occur due to various factors, including emergency manual fixes or unapproved changes. It's crucial to implement continuous monitoring solutions that actively compare the current state of your systems against their defined desired state. Any deviation, no matter how small, should trigger an alert, enabling prompt remediation. Beyond maintaining operational consistency, these audits are vital for security and compliance. Regular security configuration checks ensure that your systems adhere to established security baselines and industry standards, reducing the attack surface. For regulated industries, automated compliance checks against frameworks like HIPAA, PCI DSS, or GDPR are not just best practice, but a necessity, providing verifiable proof of adherence and drastically simplifying audit processes. This proactive vigilance is key to sustained stability. In conclusion, configuration management is not just a trend, it's a fundamental pillar for achieving and maintaining system stability in any modern IT environment. By adhering to best practices like defining desired state, ensuring idempotency, version controlling everything, automating relentlessly, embracing immutable infrastructure, and conducting continuous audits, organizations can significantly reduce downtime, enhance security, and accelerate innovation. Looking ahead, the field of CM is constantly evolving. Emerging trends like GitOps are pushing the infrastructure as code paradigm further by using Git repositories as the single source of truth for declarative infrastructure and applications. We're also seeing the integration of AI and machine learning to predict and prevent configuration-related issues, leading to truly self-healing systems. Embrace these best practices today to build a more resilient, efficient, and stable future for your systems. Your journey towards unparalleled system stability starts with robust configuration management.